Okay, hello everyone. If anyone else comes in, they'll just have to catch up, but I'm gonna start now. Uh, this is basically this is less of a talk. This is more of like a workshop. So if you're able, it's best to actually be hands-on. So the link I just sent in the chat will allow you to follow along and run the commands and everything yourself. You won't have to do anything more than just have a Gmail account. If is anyone going to do that? I can wait for you to set it up if you want. Okay. Well, that link can be used, and I'll put it in the Discord too, so that it can be. So if you want to look at it later, you can do that. So let me just one second. Okay, so a lot of if you want to learn pandas, you can learn like they have a whole website that has really good documentation. You click getting started, and they'll show you how to set everything up. So if you want to learn really get like in-depth learning of on pandas, you can click documentation, and you can do go to getting started, and there are I believe you can go so there you can look at some community tutorials. They also, I'm not finding it on their website, but they have like, if you know SQL, you can go to you can like go to their web. Yeah, so right here, this comparison with SQL. So like if you're used to SQL, you can look at all the commands and see how pandas compares with it. Basically pandas is like a programming version of SQL. So you can in Python, you can do SQL. You could like send SQL queries, and you could set up a server and everything. But Pandas is really good for just like quickly going through, pulling a like working with some small amount of data, any data that can fit in RAM, and you can use it just to do like really quick things in a Pythonic way. So if you're used to coding in Python, this is a really easy transition. If you're used to SQL, it can be somewhat easy transition too, but it works really well for those who are already used to Python. So with that, I'm gonna actually just run this code right here. So the first step is we have to import pandas. So like any import in Python, we just do import the module or package name, and then we're calling it PD, so we don't have to type pandas every time we access something. And then once we do that, we can get the data. So I just was like randomly searching for some quick data, and I found some COVID data that just has a lot of different like statistics and things, a bunch of different metrics. And so I went and found some of the data, and I got the raw GitHub links, and I put them right here. So the first one is the actual data, and the second one tells us what some of the like the metrics actually mean. And so I load both of those, and it's actually really cool because Pandas is able to read a CSV from a URL. So if you had it in your like locally on your computer, you could also put the directory, the path to it, and you could load it too. But if you also have it on a website or something, you can put it in there too. And so this will just load the CSV file. And if you've never seen a CSV file, it basically looks like this. Where let it load real quick. I'm just gonna. All right, yeah. So you have the name of each column, and then you have all the data. And it's each column is separated by a comma, and then normally you would separate each row by like a new line. And so that's what a CSV file basically looks like. And so we're just loading that. So if I run that, and just for you guys to know, I'm using Shift Enter is the shortcut that runs it and then moves me to the next line. If you wanted to just run it without moving to the next line, you can do Alt Enter, and that will run it and keep you on that same block of code. So now we just loaded it, and we can now view the table. So I'm going to click Alt Shift, Control Enter, I mean. And that will load the table, and it will display it really neatly for us. And so we can kind of get a view of what data we're even dealing with. So it has a bunch of different columns. If we want to see the columns, we can do columns, and this will just give us all the column names. a little more neatly than that CSV file did. And we can just look through these and maybe we can find some things of interest, maybe total cases, total deaths, and location is probably pretty important. And also it has date. So those are some pretty important. There's a lot of other numbers here too, but we can just look at that for now. So I'm gonna restart that. You can look at it all nicely if you want. And then I'm also gonna display the other table that's the code, what they call it, the code book. And this just describes what each column name is. So if we're looking at the data, it'll say like we have this right here. And if we can find that, then we get where's the source of this data, the description and everything else. So we won't actually be using this too much, but if you wanted to actually understand what you're working with, you could use this. So I kind of wanted to go from the approach that I just showed with the comparison with SQL. And so we're going to be looking at the SQL and then doing the Pandas version of it. If you're not familiar with SQL, that's no problem. I'll be able to explain it and we'll be able to get through that. So to understand. Before I continue, any questions, any trouble doing it? Doing any of the like the works, loading the collab and Pandas or anything? Okay, so we'll move on and we'll go to the selecting columns. So basically all selecting columns does is we pick a specific column we want and we get that all those rows. And so if we wanted location, we would get all these different locations that's in the data set. So if we look at the SQL version, you just normally do select location from COVID. And what you do in Pandas is you do COVID and location. And when we run that, you can see we get all the different countries. And then the next thing we can do when we're doing like selecting a column, we can actually make new columns. And so in SQL, you would have all the columns you just had, and then you would make a new column and name it. In Pandas, we can do it two different ways. We can make the name and just assign it kind of like you would a dictionary. And then we can do the calculation right here. The other option is to do COVID assign and then put a name here and do it like this. This is probably the more Pythonic way to do it. And then when we run this, we can see we did not originally have total cases relative, but when we type COVID.columns, we can see it's right here, total cases relative. And so all that's doing is that's just taking the total number of cases, the sum of that, and dividing the total cases. In the realistic use of this data, you probably wouldn't be doing this, but it is just a way to show what we can do with Pandas. So the next thing we can do is filter rows. So if you were wanting, let's just say, all the information for Afghanistan, so you would filter on the location. If you want all the time in all the data points in 2020, you could filter for that date. So in this example right here, we're filtering for total cases that equal 50 and new cases that equal 0. And we're taking the first 5 of that. So this is what the SQL would look like. And converting that to Python and Pandas looks like this. If you wanted to have, let's say, the first like 15, you could type 15 right there. Whatever amount you're doing. I'm only doing this because if we didn't put that there, it would just list like a bunch, and I didn't want to have a really long list. So you don't need this. You could remove that, and you get all the things that match total cases equal 50 and new cases equal 0. So if I just put that 5 right back, run that, we just filtered it, and these are all the rows that have total cases equaling 50, which interesting is 5 for 0. That's interesting. I'm not quite understanding why I did that. Yeah, I'm not quite understanding. Maybe yeah, I don't know. That's weird. But normally what would happen, and actually I think I just found the problem. This probably should do it. So you got to be careful with when you have this and here, you want to make sure you have your brackets. So if we run that again, yeah, that fixed it. Okay, so now we're getting total cases 50 and new cases 0. So yeah, just make sure if you're using this and if you're dealing with anything like numerics or strings or anything, you really just want to put that in a bracket, or else you'll be doing a bitwise operation, which can mess it up. So yeah, fix that, and then you can be able to run that and you'll get the right results. All right, so moving on to group by, this is really useful if you want to group all the different rows by a common like theme. So in SQL, you would just select the like if we're trying to get the group it by location, and get the counts of how many different data points fall in that, or how many rows fall in that location, you would normally just do select location and then count all the columns, or just you could put location in there from COVID, and then you'd group by the location. Doing that in Pandas looks like COVID.group by location, and we select, let's just look at location. If we didn't do this, we would be counting all the rows, but we don't need to count all the rows. So we just do location and we count, and you can see when we run it, we get the result, and we get all the counts, all the different rows that fall in each location. And you can also do some more advanced group bys. We can do like location and date. And this would group it, oops, forgot that. And this would group it by two different column values. So by location and by date. And so you can see how Afghanistan has this is the first index. So this is actually a multi-index series right here is the result we're getting. And so we have the first index would be Afghanistan, and the second is these different dates. So that's kind of more advanced one. And you can do as many as you want, as many as there's columns in that data you can group by. Okay, so the next thing is doing an inner join, and an inner join's pretty useful. In this case, we didn't really need to do it, so I kind of just made up a reason to do it. What we're doing here is we're taking all the data points for that fall in the year 2020, and we're calling that COVID 2020. So we just made this table, and it has all the information we want is location and total deaths. So we basically said we don't need any other columns other than location and total deaths. And then backing up to the line above, what we do right here is originally when we load that CSV file, we get these raw strings, which are dates. We're converting it to a natural pandas date time type, and that allows us to do some special things, which you can see right here. We type dt.year, and that will just get us the year, and we can compare that to 2020 or 2021. So once we do all that, we get two separate data tables. We have COVID 2020 and COVID 2021. And with that, we can do an inner join, and we can join it on location, and we can basically just put the COVID 2020 with the COVID 21 and get every combination on that location. So it's not necessarily the most useful thing to be doing, but there are cases where you would actually need to do this. And this kind of just shows how you would do that. So if you see the result, we have total for each location, we have a different, every combination we could have of the for that location of total deaths. We have also with total deaths from the 2021 table. And you can also put, like, if you wanted it to do, I believe, I'm actually, yeah, it says, let's see. I believe it's, yeah, the suffixes. You could put different suffixes. So right now we have X and Y. If we wanted to say, like, we could change it to 2020, oops, and we could do 2021. And if we run that, now it's a little more clear. We have, and actually we could even add that right there. And that now it's a little more clear. So we can do that. Now we can also move now to the left, right, and full outer joins. So these joins, normally in this join, if the location didn't exist in one of those data points, so let's just say for some reason we weren't originally tracking COVID in the United States for 2020, then when we do this inner join, it wouldn't actually have popped up in here. There wouldn't have been any combinations with it. But when we do a left join, whatever's on the left of the join week is the only thing we care about. So if COVID, if like the United States isn't reported in COVID 2021, that's not a problem. We just care about it being reported in 2020. And if we do it right, we just care about 2021 being reported and not 2020. And if we do a full outer join, that basically does not care about either. And so that just means if it's in 2020, it's there, and we get a combination of it. If it's not if it's in 2021, we do, and if it's not, it doesn't matter. So yeah, so that's basically what these joins are doing. In SQL, you can see the different ways you do it. You basically just change it left, right, and full. I believe full doesn't exist in, I don't think MySQL, or there's a couple, maybe there's a couple, but I'm not aware if you can actually do that in SQL right now. But what you can do is you can do it in Pandas. So to do the left join, you basically just change the type how and left, and it will do a left join. And for a right join, you just do that, but with right. And for a full join, you do outer, and that will do an outer join for you. So that's basically how you do all the joins in Pandas. So now we can actually do something. And so I just have, let's propose a question. So I didn't actually prepare any of this. I was just like, let's just go for a random question. And I'm just going to come up with one right now. So I'm kind of curious. Let's see. I'm curious which countries had the most cases in, let's say, 2020. So actually, let's rephrase this to, let's see, which countries, and let's just get like the top 10. All right. So the first thing we can do is we can look at the table, so we just get an idea of what we're working with. And something we want to be aware of is for total cases, the way this data works is it sums up all the cases before. I believe that's how it works. And we can, since I'm not aware of exactly how it works, we can actually get an idea of how it works by just looking at, we can filter for a location. Oops, I did that wrong. We do COVID. And then now we get all the locations and we can filter for whatever we want. And so I'm just going to say, let's just do Afghanistan. It's right there. So now we just filtered, and then I'm just going to group by the date. And let's see. So let's not group by. So first off, we have all the times right here. And so I'm just looking at the different total cases, and we can look at all these. We can like select the tables, the columns we want. So let's just take date real quick and total cases. And I believe we should be able to just plot this real quick. So this is another cool feature of Pandas, is we're able to plot pretty easily. Let's see, what did I do wrong with that? Okay, so that is not working. So one thing we can always do is we can go and search up plot, because I do not remember the exact name. Oh yeah, it should be this. Okay, so then we can go back, plot line, and I think it's complaining that I have date here. So let's just do total cases. All right, so we can see how this rises, and we can see, and then let's go back to getting just this real quick so we can look at it. So we can see how this is rising. It still is actually not telling me. I'm not quite sure if it's the total cases for that day or the total cases for all the, like for all time. So one thing we can do is we can go to the COVID code book, and we should be able to get maybe an idea from looking at total cases. And that did not work. We can filter for that real quick. I forgot the name of it. So basically what we can do is we can look, so the columns what we want. We can access the column. And I'm just going to get everything that has the column value of total cases. And what's that? Okay, so we have just this. And if we, let's see, total confirmed cases of COVID-19. So the thing we're going to go with that this is, yeah, so this is the total for all time. So so what we can do with that is, now that we know that from looking at the code book, we can remove this. We don't need that anymore. And we can remove that. We don't need that. Okay, so we have this plot. And now basically what we're going to want to do is to look at the last day of 2020. So to do that, we'll just have to filter on that last day. So let's go, we can do it right here. And I won't even delete all this because we can just go right here and we type date. And we can filter for the last day, which is going to be 12/31/2020. And that should hopefully get us all the last days. And we are going to then, with that, we can just pull, we can filter. Yeah, this would be one way to do it. Filter the values by total cases. And we will actually want sending to be, oops. Spelled sending wrong. Let's get that right there. All right, put it there. And actually, I think it's sending, yeah, false. So now we can see what are the top new total cases. And interestingly, they have this, they have these global values that they're summing in. So this is not exactly actually what we wanted. So what we're going to want to do then is go back. Let's get the table open one more time so we can see. So we have this ISO code right here, and we don't want any of these special ones. And so I think one way we could do this is we can filter. Let's assign this to a variable. So we have it all filtered. We have all the things we want. We just got to filter out the ISO codes that we don't want. And the way I'm going to approach that is if it has a this OWID right here, I'm not going to include it into the result. So basically just going to say ISO code, and we can do string contains OWID. And then to not that, we just put this tilde right there, and this should give us the final result. And so this was basically our answer to the question. And we can pull, I believe it was the top 10 we wanted to look at. And so we get the top 10. We have United States up here, India, Brazil, Russia, France, and all the ones you can look at. And that is the total cases for 2020. So that's how you would approach asking a question and just answering that with Pandas and this COVID data set. So that is basically the conclusion of this Pandas workshop. If you have any questions, you can ask in the chat. If you have any questions and you're watching the recording, you can ask in the Discord or even DM me. Thank you for attending.